ঠিক আছে।
এটা কি দেখা যাচ্ছে?
হ্যাঁ স্যার দেখা যাচ্ছে।
Okay. So actually we started with the introduction. So just a quick recapitulation. So initially we started as a computer to solve problems, right? And we said that computer is, the name computer is a misnomer. So essentially it is a data processing machine now. And to solve problems with data, we first have to make a model of the problem, and then the algorithm within the framework of the model, and then data has to be represented within the computer. Okay. We also said that the different data models and operations, etc., are required to be understood for objective solution. Now, then we discussed what is a system, what is a model, and then how to develop a model and things like that. And models should be accurate enough and practical. Then we discussed about what is information. When we talk about programming, what is information and what is data, right? So data is an abstraction of information in the problem-solving system. Right. So then we also discussed various forms of data, and we discussed about data types, and data values are interpreted according to their types. And type actually is a set of allowable values and a set of allowable operations. So different types of operations, though they have the same symbol, they have different semantics. That also we discussed. Finally, we started discussing the program structure also, program structures, right? And we said that there are these number of structures, right? So today, just let me digress a little and discuss a little bit detail of this algorithm structure. Okay. So essentially, the algorithm structures are like this. So initially, first we have the sequence structure, and the sequence structure, the flowchart is like this, right? And this is a statement, this is another statement, followed by the other statements, and followed by SN, and finally it is out. And then we have the C language statement for that is like this. So this we discussed. Just note here that we have a single entry point and a single exit point here. Right? So the flowchart shows that there's a single entry point and a single exit point. So then we have, this is sequence, then we have the conditional structure. There are three conditional structures. One is an if structure, the other is if-else structure, and the third one is a switch structure. So if you look at the if structure, then this is the if structure. So if condition, then statement. So then is not there, then as a keyword is not available in C, but there are other languages where then is a valid keyword, okay, or a reserved word. Now here the condition is tested. If the test becomes true, then the statement test1 is executed. Otherwise, if the condition is false, then you come out. And again, you can find out that this is a single entry point and single exit point kind of structure. Okay. And the same is with the if-else structure, where the condition is tested. If it is true, you execute S1, else execute S2. Means if it is true, you execute S1. If it is false, you execute S2, right? And so finally, what you get is if condition S1, else S2, right? And this else and if are paired. And there is a problem if you have the condition, I mean the nested conditional statement or nested if-else statement or nested if-else along with if statements, then there is a problem of associating which else corresponds to which if, and there is a method for that. I think you know all these things. Right? So this is what the conditional structure, if and if else, and we also have a switch conditional structure. So here also we have an expression to be evaluated. Since it is a multi-valued output, so there is an expression to be evaluated, and if the expression evaluates to V1, then you execute S1. If the expression evaluates to V2, value 2, then it then execute S2 like that, and finally, if the expression evaluates to Vn, then you execute Sn, and finally you come out. So this kind of flow, right, can be achieved by the switch facility. Right? So the syntax is switch expression. This expression is here. So expression is evaluated, and there can be various values of the expression v1, v2 up to vn. And for each value, you have its corresponding statement followed by a break. Why the break is required? Just to come out of this whole block, right? So this is why the break is required. So just remember that you can also use break anywhere, right? Anywhere in the program you can use break. What will happen? The control will come out of the closest structure, closest algorithm structure. So it is not necessary that you use breaks in switch or iteration only. You can also use breaks anywhere in the statement, right? In the program. What the break does is it comes out of the closest structure, algorithmic structure. So now, so this is what is a switch statement. If you do not give a break here, what will happen? Suppose this break is not here, then what will happen? Anybody?
After, if S1 is, V1 is valid, then V2 will be executed.
Every case will be done,
executed until another break is encountered.
Right. So it will be a sequence. It will be a sequence of statement until another break is encountered. Okay. So break is not necessary that way, but in order to achieve this kind of a single entry, single exit structure, you need a break here. Okay. Come in. তুমি একটু লাভে ওয়েট করো, ক্লাস হবে 5 মিনিট ইয়ে আছে so this is what is a switch structure, right? And again, this is a single entry and single exit point, single entry point and single exit point. And in order to have a good programming habit, you should always maintain this, right? So then we have the iterative structures. Iterative means loop structures.
Sir.
Yes, please.
একটা ডাউট ছিল, এই কেসটাতে যদি ব্রেকটা না দিই অন্য কেসগুলো কি মানে এক্সিকিউট হবে না, জাস্ট দেখে বেরিয়ে যাবে? মানে
না তুমি ব্রেকটা ধরো, তুমি ভ্যালু ধরা যাক এই দুটো ব্রেক তুমি দাও, এবার এক্সপ্রেশনটা এসছে v1, এক্সপ্রেশনের ভ্যালু এসছে v1। যদি এক্সপ্রেশনের ভ্যালু v1 হয়, তাহলে S1 S2 করে যখন একটা ব্রেক পাবে তখন বেরোবে, রাইট? কিন্তু ধরা যাক এক্সপ্রেশনের ভ্যালু এসছে v2, তখন এইখানে ঢুকবে, বুঝতে পারছো? তখন S1 এক্সিকিউটেড হবে না, S2 S3 করে এক্সিকিউটেড হবে, ফার্স্ট যেখানে ব্রেক পাবে সেখানে বেরোবে। এগুলো না যখন ডাউট হবে, ছোট আমি যা বললাম সেটাও যে ঠিক, সেটাও তো দেখে নেওয়া দরকার, বুঝতে পেরেছো? ছোট ছোট প্রোগ্রাম লিখে কম্পাইল করে জাস্ট দেখে নেবে যে কিভাবে কাজ করছে, টেস্ট করে দেখে নেবে যে আমি যা বললাম বা বইতে যা লেখা আছে সেগুলো ঠিক কিনা। দ্যাট ইজ বেটার, বাট দ্য কোয়েশ্চেন ইজ গুড। ওকে, then iterative statement, there are three possible iterations in C. So one is a while structure. So in the while structure, you have this first checking the condition, then the statement S1 is executed, and again the condition is checked, and this will go on looping until the condition is false. When the condition is false, you come out, right? And if you look at the while loop, it is also a single entry point and a single exit point structure. The same is like do while, where the statement is executed first and then the condition is checked. If the condition is true, then the statement is again executed and again the condition is checked and so on. Finally, when the condition becomes false, you come out. Right? So in these two cases, the condition should be such that the condition and S1, the statement and the condition should be such that initially if the condition is true, then after some time, some iterations of executing S1, the condition must go false. Otherwise, it will be an infinite loop. So there should be a dependence between the parameters of the conditions and the parameters which are manipulated using this S1. This S1 may be a single statement or even a sequence of statements, maybe another loop and so on. Right? So the same thing if with S1, with the do while. When the condition is checked first, if it is true, then S1 should be such that finally the condition should, after some iterations, the condition should become false when the control will be taken out of this particular structure. And again, this is a single entry point, single exit point structure. Okay. So this what is the other difference between these two? Anybody?
স্যার ডু whileটা at least একবার S1 টাকে এক্সিকিউট করবে
Do while, in the do while, the executed at least once, whereas in normal while, S1 may not at all be executed if the condition is false at the very beginning. Okay. Thank you. Okay. Powerful statement, which is for. Okay. For is the most powerful loop statement. Okay. So for, first let us see the syntax. So in for, actually the header of the for has three components. One is an initialization statement, another is a condition, and finally is an implementation statement. Okay. So three components of the for header. Right? And of course the body of the loop is S1. If it is a sequence, then there should be brackets and so on. That you know already. Now the point is, this initialization statement and the increment statement can be anything. Normally we are familiar with I equal to 0, then I plus plus, or I equal to 1, I plus plus kind of thing. Right? Maybe the condition is I greater than equal to, or I less than equal to, whatever. Right? So these are popular examples, but actually the initialization statement can be any statement, condition can be any condition, and increment also may not be a real increment, but something which changes the parameters of the condition. Okay. So this is a for statement. That's why I told you that this is a very powerful and most powerful statement. For statement is the most powerful statement. So when you draw the flowchart, it will look like this. So init is the first thing. So outside the loop, init will be executed. Then the condition will be checked. If the condition is true, then S1 will be executed, and then the increment statement will be executed. Again, the condition will be checked. So initialization statement will not be taken at all, right? And this is for the first time it will be executed. Otherwise, S1 and increment is always executed within each iteration, and after each iteration, the condition is checked. Or before each iteration, the condition is checked. If the condition is false, then it will come out. And again, if you look at this is a single entry point and single exit point structure. Right. So this is about the for loop. And theoretically, if you have the sequence, the conditionals, and the loops, then you can write any program. Any program can be written with this. And in order to facilitate programming, large programming, we have this subprogram concept or the recursive subprogram concept. The idea is in one function or in one body of the program, you have a call to the function F1. When the function F1 is called, then the control will be transferred to the function F1. All the statements within the function will be executed. It may or may not have any return statement. So after that, it will come back to the statement after this call to F1. Right? So after this call to F1, this will return. Okay. So this is what is happening in the call return mechanism of the subprogram. And this also you know very well. And you also know recursive subprogram, where these two functions are the same, right? These two functions, the code is the same, and you can call the function from each cell. So that is also possible. Right? We see we allow this. Right? You may be surprised to note that up to Fortran 4, right, recursion was not allowed. Recursion was only allowed in Fortran services. Right? So for the past about 20 years, recursion was not allowed in the language Fortran. Right? But recursion was allowed in Algol, I mean languages like Algol and other languages. So anyway, so that is the kind of thing which is happening. We'll discuss in detail as a topic of discussion the recursion, its implementation, and different forms of recursion later. The other thing which we discussed in the slide was control transfer, and there are 4 basic control transfer statements. One is go to level, return, maybe return with a value, and then break and continue. So these are the 4 control transfer statements. Okay. Right. So now let us very quickly discuss. I mean, what is the problem and what are the virtues of structured program. Well, if you go to the note, now you know, without structured program, your program and your program flow, control flow, may look like this. Say these are the statements of your program, right? And you have used go to, etc., anywhere. So maybe at this point there is a go to this. After some time, there may be a go to this. Then there may be a go to this. Then there may be a go to this, and so on. So this is called a spaghetti type of structure. Spaghetti, I think there is an H here. Spaghetti kind of structure. Spaghetti means quickly na, you bolte paro eta ekta chow-mein type of a spaghetti. So basically the structure is like this, and it will be very difficult to debug these kind of programs. Okay. Because once there is a problem, you don't know where the problem is has happened, where the bug is, and it's extremely difficult to debug this kind of control flow. Okay. Instead, if you have a sequence kind of structure, so you have a block of statement like this, then you have a block of statement like this, you have a block of statement like this, okay, and very well defined structures. Then what you can do is you can really look at the, suppose you look at this, right, at this point. Right. You can find the different points where the blocks end. Okay. Now, if there is a problem, then you can insert certain write statement. Okay. Some parameter you can. So you can insert some statement here, which we call spy write statement. Spy write statement. So here you can insert one. Here another spy statement can be inserted, and so on. Right? So what will happen? You can localize the bug. Suppose the program is not working, then with known input, you run the program and you insert certain spy write statements over here. So you first, in each point, you will output certain parameters and find out whether the parameters are having the proper values. So maybe here the parameter values are okay, but here the parameter values are not okay. Then you have already localized the bug here. Okay. And then you can go for scrutinizing this particular loop. Okay. Otherwise, it is very difficult for a large program. It is very difficult to debug things. The other possibility is, I mean, your structures are basically nested. Okay. All the structures can be nested. So that here you can have, say, one loop, outer loop, right? Within one outer loop, you can have an inner loop. Within an inner loop, you can have a maybe a conditional and so on. So there can be nesting of those structures, which or 7 structures which we have discussed. They can be nested. Okay. So you can definitely find out which are the points where you can write, where you can insert those file guides. Okay. And then you can find out the one very quickly. Otherwise, it is very difficult, right? So nested structures. Okay. The algorithm structures allow nesting, and any level of nesting is allowed, right? So the structured programming actually helps you to debug the whole thing. So and it is found out that you can do away with go-to statement. Okay. Right. Go-to statement, you may not need the go-to statement. So that way, there was a paper, technical paper, which was termed as go-to considered harmful. Harmful. Okay, go-to considered harmful. Why? Because if any programmer uses unlimited go-to, then it will be like this, right? Spaghetti structure will result, and if the spaghetti structure results, then you will have difficulty in debugging large programs. So go-to was considered harmful. This I'm telling you, mid 1960s. Okay? Mid 1960s, there was debate whether there should be structured programs or there should be a normal unstructured program. Okay? So this was a paper, and this paper was discussed by many people. And then after about 2 years, there was another paper which said that go-to considered harmful considered harmful. Okay. Go-to considered harmful, considered harmful. So that was a second paper, which actually was written by somebody else who pointed out that if you only give these structures and no go-tos, right? Then there may be a very difficult problem of writing certain structures, algorithmic structures. So you have to have a very roundabout way of writing programs. Okay. So then finally what was accepted is that as far as possible we should use structures, right? And we should use go-tos, right? Or break or continue, etc. sparingly, right? So use them judiciously. Only when you know exactly when go-to is required or when break is required, when continue is required, only use them in that situation. Like suppose there is an exception in the program. In that case, you can, whenever there is an exception, you can go to some exception handling routine. So that is normal, a normal go. Okay. That does not make your program, I mean the structure of the program, to be a spaghetti-like program. Okay. So there are these issues, and why I have introduced this concept is not only for writing large programs, but also for analyzing algorithms. Okay? Algorithms are analyzable if you use structured algorithms. Okay? If you have a spaghetti-like algorithm, then the algorithm analysis is almost impossible. Okay. So that is the discussion on program structures, right? And we will be following this, right? We will be following this kind of situation. Normally, we will be using structured programming, and only sparingly we will use GoTo and other control transfer statements. Okay. So, any question at this point? Anybody? কারো কোনো প্রশ্ন আছে এখন এই যে বললাম এটাতে
So can you please repeat the use of the spy right statements?
Which one? Please tell me.
Sir, can you please repeat the use of the spy right statement?
Spy right statement. Okay. Yeah. The spy right statement is used for debugging. Okay. This is used for debugging. So these spy right statements are used for debugging. Okay. So when you find out that your program is not giving a proper result, then you can include certain statements, right statements. By looking at the output of those right statements, you can find out where the localize the part, right? For example, if there is a problem in this structure, then this right statement will give you a wrong result. But if this block of statement is good, I mean no bug in this, then this right statement will give you proper result. But maybe this right statement will not give you the proper result. So the error or bug definitely is within this block and not in this block. Okay. Right. So should I explain? Okay. You understood, huh? Okay.
Yes, sir.
So without the debugging tools, without any debugging tool, you can also use this kind of spy right statements. Any other question? Thank you. Thank you for this question. Any other question? Any other comment or question or clarification? Anybody? So it seems that you have understood this, and in the lab we'll be discussing this, right? Now the other point which I want to make note of is, the other point is how to write a large program. How to write a large program? How to write a large program? Anybody?
আমরা ছোট ছোট ফাংশন ওটাকে ডিভাইড ছোট ছোট মডিউলে ভাগ করতে পারি ওটাকে একটা বড় প্রোগ্রাম
The mantra for writing a large program is never write a large. So never ever try to write a large program. And what we should do is, as somebody was commenting, that we should always break down the program into problem into a number of sub-problems and develop certain modules out of those sub-problems. Okay. And usually we should not write more than one page functions. The functions, the source code of the function should not be more than one page usually. Okay, but there are certain situations where you can write, say, maximum 2 pages or 3 pages of functions. Why this is important? Because when you read the program, it is very difficult to correlate the different statements if the statements are in different pages. Okay, so the page size or the function size should be less than one page, usually. Okay. And if you cannot accommodate in a page, you can go for at least, at most 2 pages and not more than that. If it is more than two pages are required, usually you can break down the function into, again, 2 sub-functions, kind of. Okay. So these are some of the very practical hints, practical tips for writing large programs. And you can, if you look at the source code of any of the large programs which are available, there are a number of source codes of large programs are available on the web. You will find out that they have never written any large program. They have always broken down the problems, and then they have gone up, and each function is a small function, usually within a page, or usually maybe maximum 2 pages. You can just look at that. You can print you can print the so-called functions, and you can see what is the length of that.
Sir, but while defining, while writing, how do we measure that this is one page? Because there is no such kind of indication that so and so number of pages.
A very simple idea is to copy the program and paste it on a Word file, right? You'll find out whether that fits in the page of the Word, Microsoft Word. That is another practical tip. You understood?
Yes.
Okay. So now let us turn back our attention to the presentation, where actually we so program structures we have more or less understood, but again you have to practice it, structured programming, and then only you will be understanding the virtues of structured programming. Okay. Data types also we discussed, right? And structured data types also we discussed. So in structured data type we will have components, then structure defined by the set of rules that put the components together, and the structured data type. It can be a single dimensional array, it can be multi-dimensional array, it can be array of structures, it can be simple structure, it can be an array within structures. So whatever you have, what you have is the structure of this structured data type will be defined by the set of rules that put the components together. How the components are put one by one or side by side. Okay. So this is what is the structured data type. Now let us go over to the abstraction of this kind of a structured data type. Okay. So abstract data type, or ADT, this is a very important concept, and this will be there throughout your life. So a conceptual model of the information structure. An abstract data type is a conceptual model of information structure. And we have already discussed what a model is, right? So what we'll find out here in the information structure, we'll find out the different components of the information structure and how the components are related amongst one another, right? What is the correlation among the different components, right? So out of that, so the conceptual model of information structure is like you have different components of the information structure and the relationships among the information structure, right? I mean the components of the information structure. Now, what we have to find out here as a model, what we have to find out, what are the different properties of the information components, and what are the properties of the information, the relationships among the information components, and then you take a subset of those properties, and that will be the model. Okay. So we'll find out later how we can come to this kind of conceptual models. Okay. Now, an ADT actually specifies the components, their structuring relationships, and the list of operations that are allowed to be performed. You should memorize this line, what an ADT is. I have seen, even in interviews, I have seen people that cannot define an ADT. right? People doing PhD cannot even define an ADT. And this is so basic to computer science that you should memorize this and you should quote from memory whenever you read. Now you can find out this particular line, right? That particular sentence. Actually, this sentence is nothing but an abstraction of the previous sentence. Okay, the structure data type. We have the components, we have the structures, and we have the set of operations in case of structured data types. What we have done here is exactly abstracting that, right? Conceptualize or abstracting that. So we have the components to be specified, their structuring relationship to be specified. Again, structuring relationship means which component will sit after which component, or which component sit above which component, and things like that. So this kind of structuring relationship will be there. Just one moment. তোমার ফোনটা পাওয়া গেছে আলটিমেটলি, মানে ফোনটা পাওয়া যায়নি, ফোন একটা নতুন কিনে নিয়েছিল, কি করেছে? আচ্ছা আচ্ছা আচ্ছা, সেটাই ঠিক আছে। না না ঠিক আছে, কোনো না ঠিক আছে, আমি তুমি তো সোমবার আসছো নাকি? ঠিক আছে ঠিক আছে, ওকে। So those relationships should be there, and then a list of operations that are allowed to be performed. Now the point is, this is a specification. Okay? This ADT actually is a specification. It does not require any representation or operation implementation, nothing. Okay? So they are only the specifications. So that you should very well understand that there is a difference between the specification and its implementation. Okay. So the ADTs are independent of data representation and implementation of operations. That you should understand. Okay. This just a specification, no design or implementation information is included. Okay. So that is extremely important, because if you cannot specify something, if you jumble up the specification with the design, then there is a problem. I mean, the conceptual thing will be lost. Okay? In most of the cases, that happens when a new structure is defined. Okay? And of course, these components, which are their individual components, they can be themselves other entities. Like you can have an array of structures. Okay, so array is an entity. Structure is an entity. Struct is an entity. So array of structs means the individual elements of the array are another entities. Right? So that way, the components can themselves be entities. It is like your algorithmic structures, but the structures can be nested. So here also the entities can be nested. Right? One entity inside another entity. So that is possible. Right? It can be an array of arrays. That is also possible. Right? So these are the kind of conceptualization or hierarchical conceptualization. Okay. If you fail to understand anything or you need clarification, immediately you can stop me and ask questions. Okay. Don't wait for me to ask you whether there are any questions. So any clarification required here?
Sir, can you give the clarification about the third point? ADTs are independent of data representation and
implementation of operations. Now, what you do is you at the very beginning, the first statement, the second statement, you have the specification of the list of operations. So essentially, you can say for integer, right? If integer is an ADT, then you can say that the integer ADT should support the operations, say add, subtract, multiply, and divide. Okay, right? Now you need not say, or you need not include how the integers are to be added or how it is to be subtracted. Okay? You have to define addition and subtraction, but you need not show how they are implemented in the programming language. Okay. So that is what we mean by independent of data representation and implementation of operations. I'll come to that in the next slide again. Any other question? Anybody else? Any other question in this slide?
Sir, what is meant by no design? Shouldn't an abstraction involve the design?
It is just a specification, right? Specification means what is it, not how it is done. Design is how it is done, and implementation is that implementation of the how. Okay. Implementation means actually executable something. Design is a representation of that executable, and specification is a representation of what is to be done. Could I explain, or I should elaborate?
It is.
So what is ADT in itself?
Sorry.
So what is ADT in itself? Like what is it? It is a block.
ADT has
block of structure.
ADT has three things. One is the components, one is the structuring relationships, another is the list of operations. That whole thing is an ADT. Abstract data type, like
So
in
it is a
the
block.
sorry,
Like it is a block. Like it is a block. Sorry, any block which has components and structure.
It is not a block. It is not a programming concept. It is a conceptual thing. You can say that it is a triplet of mathematical triplet. Like ordered pair, you can have mathematical triples also. So it has got three components in the triple. One is the components of the ADT, the other is the structuring relationships of the ADT, and the list of operations. Okay. Nothing to do with programming.
Okay.
Programming will come after this. After you can define what you need, then only you can implement it, or you can design and implement it. So there are three stages actually. One is the specification, where you express your expectations, right? Then the design. In the design, you try to spell out how you satisfy those expectations, and in the implementation phase, you satisfy the expectations using the design methodology in an executable format. I'm repeating. In the specification stage, you just say what are the expectations. Okay, what do you expect from this structure, right? In the design phase, you find out, you try to explain how you can satisfy those expectations. Okay? And finally, the implementation stage, you come up with something which is executable following the design methodology. Okay. Any other question here? I think we can now progress, because a lot of questions have been asked already and some clarifications are there. So if you progress, then you will be able to be more understanding. So the first bullet here says that no assumption is made about the range of values of the components. Since it is an abstract data type, if I say it is one of the components of this ADT is integer, one of the components of this ADT is an integer, then we are not saying at the ADT level, we are not saying whether it is minus 65,000 to plus 65,000. Nothing like that. Integer is an integer, minus infinity to plus infinity in the abstract level. So there is no assumption made about the range of values of the components. Or if I say it is an array, then we are not saying it is an, it can be say 64,000 elements can be there. We do not say like that. An array is a finite sequence, that's all which we say. But what is that finite, or what is the maximum value of that finite size, that we are not saying in the ADT phase. Okay. So no range of values is given. And as I have already told you, specification involves the what's of the operations and not how. What the operation will be, but not how it is done. Okay. The how part is actually done in the, how part is actually explained in the design phase. Okay. And as you have already understood that ADTs are generalizations of the primitive data types. Primitive data types are what? Say integer or float or char, like that. Those are primitives. And of course, then we have the structured data types, and ADTs are generalizations of those structured data types. Okay. And like the objects, ADTs also encapsulate data values. I think you have already started the object-oriented programming. So in an object, actually what you do is you are encapsulating the data value. So here also, in a sense, you are encapsulating data values, but the security is not that much. So there are not, constraints are much less in normal ADT and C implementation. No, any question? I think these are the clarifications of what we have already discussed. Okay. So now we have got some components, and somehow we have structured them, right? So what are the operations? What are the generic operations? The generic operations are like this. So you can create and dispose the data abstraction. Then, since it's a structure, so you can insert data element or component into the data abstraction as per structural relationship. So you've already defined certain structural relationship. So using that, as per those structural relationship, you can insert certain data element or component in that structure. Okay? So that is what is the insertion or insertion of the elements, right? Then after you insert them, you must be able to access or search that data element or the component in the populated data abstraction. So you have an empty structure, then slowly you have entered a number of data element or insert or enter some data elements, and then you can search the entered data elements. Search also, if the element is not there, it will show you that the element is not there, right? And finally, you can remove the data element, right, or delete the data element from the populated data abstraction. So these are the generic operations, right, which will also follow, right? And these above operations are structural in nature, which means that these operations are manipulating the structures, right? Not the values. The structure, individual values are not manipulated by the ADT operations. Okay. In addition to all these things, there may be some domain-dependent operations also. Okay. So there can be some domain-dependent operations. We will come back to these with different examples later on, not this class, in other classes. Okay. But for the time being, we have these first 4 bullets which are important. So you can create or dispose a structure. You can insert or enter data elements or component into the structure. You can access or search the data elements from the structure or inside the structure, and then you can remove or delete the structure. So these are the 4 types of operations which you can do, and there are, in addition, there are some certain testing conditions, like whether the structure is empty, whether the structure is full, and things like that. So those are additional testing operations which are not really manipulated. Okay. Now we come to the term data structure. So after we have specified an ADT, for that ADT, we can have the design representation. So that design representation of the ADT is called a data structure. Because at the ADT level, we don't have any representation of the data or any representation of the operations. Okay? We have only the structures noted, but how the structure is implemented, that was not there in the ADT. But in the data structure, we have to, each and every element we have to specify. I mean, we have to represent in the form such that it can be finally translated into the program. So a data structure is basically the design representation of the ADT. Okay. So the same ADT may be represented by several data structures. Right? So for example, say real numbers. real numbers, how are they represented? I mean, the floating point numbers, you can represent them by using int.int format. Okay? So this is the whole number part and this is the fraction part, right? So that is one possibility. The other possibility is int comma int, this pair, okay? Ordered pair. So in the so in a suppose we want to 123.56, right? This point actually separates out the whole number part and the fraction part. So this is a representation. The same thing we can also represent by an ordered pair 123 and 56. But this is the whole number part and this is the fraction part. Okay. So all the possible floating point operations can be done on this pair also. That is also possible. Okay. For example, if you add say these two floating point numbers, right? Then what you will get if you add them together? Then you will get 124.76. Okay. Right. But the representation is in the form of an ordered pair. So depending on the representation you choose, data representation you choose, right? All the operations, algorithms of the operations may change. Because what are the operations in floating point? Maybe plus, minus, etc., etc. So all these operations may change when you change this representation. Okay. So that is an important issue when you talk about this when you talk about the representation. Okay. Representation means the data structure or the design representation of the ADT. Similarly, there can be various data structures corresponding to the ADT set. Set is an ADT, right? So you can have different representations for set. Okay. If you take a particular representation of set, then all the set operations, algorithms will be changed. Okay. Now the operations on data structures are represented as algorithms. Operations on data structures are represented as algorithms, obviously, right? Because they manipulate the structures, right? And in order to manipulate the structures, you need certain algorithms. So for each operation, you must be having one algorithm. Okay? And then the relations, if the relation among the components are not implicitly known, then they can be expressed separately. So to another data structure, you can represent the different components of the relationships on the components. Or the components can be augmented to include additional fields that represent structural information, and these components are called as nodes. In the second part, first part is simple. The second part is basically, if you take the case of a linked list, right? Linked list, right? Then you can represent the linked list as pointer-based implementation. Okay. So what you can do is you can represent a linked list by a component followed by a pointer, which will be pointing to another component, and then another component is attached to it using the pointers. Okay. So these pointers are not the actual values; they are the structuring components, relationship for the which actually additional fields that represent structural information. Okay. So these pointers represent structuring relations. Okay. So this component is related to that component. This through this pointer. Then this component is related to that component through this pointer, and so on. So these are structuring, additional fields which are structural, which represent structural relationship among the components. So, and there can be more than one such pointers. Okay? That is possible, right? Structural relationship. So, in that case, this whole thing will be called a node. A node usually is having some component values along with some additional fields which give you some structural information. Okay. Now, we are using pointers, but this can be this kind of linked list can also be represented by simple integers here. Right? That is also possible. We'll see later on when we talk about linked list. We'll see that this is also possible. But this whole thing, then also this whole thing will be called a node. Right. Okay. So this is over. Then finally, these data structures are implemented using the facilities of the programming language. So you can first you develop a specification, which is an ADT. From the ADT, you go for the design. The design you form out of different design. You can develop different designs based on the representation of the data elements and their structural relationship. Once you do that, then you can go for a particular implementation, a particular design to be implemented using a particular programming language. So you can develop or implement the design using either C or Python or C++. So any programming language will do. Only thing is that the programming language usually should have some structuring concepts and some structured kind of algorithmic structures. So that it should support, otherwise it will be difficult. Okay. So what we use as data structures in the implementation is an ADT restricted at the levels of design and implementation. Okay. So for example, somebody was saying that whether they can use the STL, right? Standard template library, right? Now STL, it is an implementation, right? So when you implement that, when you use that, you must understand that there are certain restrictions too on at the design level as well as in the implementation. So it is, and that if you do not know that, then at some point in the program life cycle, the program may fail because of the data structures restriction we have not understood. Okay. So up till now, if there are any questions, you just tell me, because I have only one more slide and then I'll stop. Any question or any? কারো কোনো প্রশ্ন আছে? তো ক্লাসের শেষে রোহিত জয়েন করতে যাবে, ঠিক আছে? জয়েন করুন। হ্যাঁ
স্যার,
এনি কোয়েশ্চেন?
স্যার আপনি তো বলছিলেন এডিটিটা ডিজাইন স্টেপটার প্রিভিয়াস স্টেপ, যেখানে খালি স্পেসিফিকেশন থাকে, তাহলে এডিটির ডিজাইন লেভেলটাকে রেস্ট্রিক্ট করছি কি করে? মানে ও তো জাস্ট স্পেসিফিকেশন।
না একটু বলো একটা দাও, আমার মনে হয় তোমার বুঝতে একটু ভালো লাগছে। এই যে এডিটি রেস্ট্রিক্টেড অ্যাট দ্য লেভেলস অফ ডিজাইন, যে মুহূর্তে তুমি একটা পার্টিকুলার ধরো ইন্টিজার বলেছিলে, তো ইন্টিজার একটা কম্পোনেন্ট ছিল ইন্টিজার, তাহলে ইন্টিজার যখন বলেছিল তখন -∞ to +∞ ছিল। The moment you say that I will design it or represent this integer component of the ADT using int, right? যে মুহূর্তে এটা তুমি বললে না, বা ইন্টিজার টাইপ বা লং ইন্ট টাইপ, এটা যখনই বলে দিলে তখনই কিন্তু একটা রেস্ট্রিকশন এসে গেল অন দ্য ভ্যালু। বুঝতে পেরেছো?
হ্যাঁ স্যার, বুঝতে পেরেছি। এটা ডিজাইন যখন ডেটা স্ট্রাকচারটাকে এডিটিতে ইউজ করে ডিজাইন করছে তখন রেস্ট্রিক্ট করছে। আবার যখন ইমপ্লিমেন্ট করছো, মানে যখন প্রোগ্রামিং ল্যাঙ্গুয়েজে ওটাকে নিয়ে যাচ্ছ, তখন আবার প্রোগ্রামিং ল্যাঙ্গুয়েজ, অপারেটিং সিস্টেম ইত্যাদি সব রেস্ট্রিকশন এসে যাবে। তুমি হয়তো প্রোগ্রামিং ল্যাঙ্গুয়েজে বললে যে তোমার যে ম্যাক্সিমাম অ্যারে সাইজ মেবি সে 1 MB বা এরকম কিছুটা বলে দিলে 10 MB,
ইত্যাদি জাস্ট একটা এক্সাম্পল দিচ্ছি, এটা তুমি বলে দিবে, ওকে। কিন্তু যখন তুমি ইমপ্লিমেন্ট করলে এবং রান করলে তখন দেখা গেল যে তোমার অপারেটিং সিস্টেমে ওই জায়গাটাই নেই, অপারেটিং সিস্টেমে তোমাকে অতটা জায়গা দিতে পারে, তাহলে ইমপ্লিমেন্টেশন লেভেলেও একটা রেস্ট্রিকশন চলে আসতে পারে, যেটা ডিজাইন লেভেলে ছিল না, ওকে। সো এসেনশিয়ালি ইট ইজ আ ডাবলি রেস্ট্রিক্টেড কাইন্ড অফ কনসেপ্ট যখন তুমি ইউজ করছো ডেটা স্ট্রাকচার। কোনো রেস্ট্রিকশন, the moment you go for design, you introduce knowingly or unknowingly some restrictions, and then when you implement by using some programming language, again there are restrictions. এবং runtime বেশ কিছু restriction এসে যায়। So all these things you must understand that তুমি একটা implementation তোমাকে দিয়ে দিল, তুমি ধরে নিলে যে ওটা আইডিয়াল ADT implementation, there cannot be any ideal ADT implementation. That is my submission. এবং আমি দেখেছি অনেক জায়গায়, আমি কেন সবাই দেখেছি যারা একটু এক্সপিরিয়েন্স তারা দেখেছে যে এইখান থেকে অনেক প্রবলেম শুরু হয়। অর্থাৎ তুমি বেশ কিছু ওপেন সোর্সের, ধরো তুমি ওপেন সোর্স কেন, তুমি এমনি ক্লোজ সোর্সে তুমি কিছু লাইব্রেরি টাইব্রেরি নিয়ে তারপরে লাইব্রেরি রেস্ট্রিকশনগুলো তুমি জানো না, তোমাকে সোর্স কোড দেওয়া হয়নি, এবার তুমি ইউজ করতে গিয়ে তারপর দেখলে একটা জায়গায় গিয়ে ঝাড় খেয়ে গেল, একটা জায়গায় গিয়ে আটকে যাচ্ছে। এবারে তুমি ডিবাগ করতে করতে একটা জায়গায় দেখলে যে ওই যে লাইব্রেরিটা তুমি ইউজ করছো এই লাইব্রেরিটা একটা পার্টিকুলার লেভেলে গিয়ে কাজ করে, সেটাই আমি মানে কেন হয় সেটাই বলার জন্য এটা বললাম। তুমি যেটা সাপ্লাই করবে তারও একই জিনিস হবে, সেটা যদি কেউ না বুঝে ব্যবহার করে সেটাও তারও সমস্যা হবে। Any other question? Anybody else? মানে এখন তোমাদের এটা বুঝতে একটু অসুবিধাই হবে, তার কারণ হচ্ছে এখন আমরা যেটা বললাম এখনো পর্যন্ত অনেকটাই abstract. The moment you go for implementations using C programming language, যখন implement করতে যাবো তখন দেখবে lot of problems will come. এবং তখন এগুলো মিলিয়ে নিতে পারবে, আমি যেটা বললাম সেগুলো মিলিয়ে নিতে পারবে। Anybody else now for any question? Okay, আমার মনে হয় কেউ খেলতেও চলে যেতে পারে, ডিটেল হয়ে গেছে। So we'll complete with the next slide. So the next slide is two generic type of data structures are there. One static and dynamic. Right? Static data structure and dynamic data structure. What is a static data structure? The memory requirement of static data structures is fixed at the compile time. Compile time তুমি যদি বলে দাও যে তোমার 1000টা অ্যারে এলিমেন্ট আছে, তাহলে থ্রু আউট দ্য লাইফ টাইম অফ দ্য প্রোগ্রাম এই 1000টা অ্যারে এলিমেন্টই থাকবে, তার বেশিও নাই তার কমও নেই। ওকে, সো দ্যাট ইজ হোয়াট ইজ আ স্ট্যাটিক ডেটা স্ট্রাকচার। But in case of dynamic data structure, the structure itself can shrink and grow at the runtime. প্রোগ্রাম যখন চলবে তখনই তার লেন্থটা বাড়তে পারে, কমতে পারে, তুমি নতুন এলিমেন্ট ঢোকাতে পারো, পুরোনো এলিমেন্ট বার করে নিতে পারো, তাহলে ছোট হয়ে যেতে পারে এই জিনিসটা। ফর এক্সাম্পল তুমি ধরো লিঙ্ক লিস্ট বা স্ট্যাক এগুলো যখন করবে, এগুলো করে থেকে যাই না, যদি করো তাহলে দেখবে এগুলো আপ ডাউন করে, আর এর লেন্থটা সেটা আপ ডাউন করে, তাহলে এইগুলোকে আমরা বলছি ডাইনামিক ডেটা স্ট্রাকচার। কিন্তু যখন তুমি ডাইনামিক ডেটা স্ট্রাকচার ইমপ্লিমেন্ট করবে প্রোগ্রামিং ল্যাঙ্গুয়েজে, তাহলে প্রোগ্রামিং সিস্টেমে তোমাকে মেমোরি অ্যালোকেশন এন্ড ডিঅ্যালোকেশনের জন্য ফাংশন দিতে হবে। তো সিতে মেমোরি অ্যালোকেশন আর ডিঅ্যালোকেশনের জন্য কি ফাংশন আছে?
malloc or free.
Right. So there are two functions in C. One is called malloc, one is called free. আমরা যখন ডাইনামিক ডেটা স্ট্রাকচার ইমপ্লিমেন্ট করতে শুরু করব তখন আমরা এগুলো নিয়ে আরেকটু আলোচনা করব, তোমরা একটু দেখে নিতে পারো হোয়াট ইজ malloc and what is free. These are basically functions given in the C standard library. এটা কিন্তু C এর স্টেটমেন্ট নয়, মাথায় রাখবেন। আচ্ছা, The last comment in this topic is algorithms and memory usage of data structures should be as efficient as possible. এটা কেন, এটাকে স্পেশাল একটা কমেন্ট আমি কেন করলাম? আমরা এখানে বলছি যে অ্যালগরিদম আর মেমরি এই তো দুটো জিনিসই লাগে, এই দুটো জিনিস অত্যন্ত এফিশিয়েন্ট হতে হবে। ডেটা স্ট্রাকচারটা এমন হতে হবে যাতে তার অ্যালগরিদমগুলো খুব এফিশিয়েন্ট হয়, আবার মেমরি ইউসেজও কম হয়। এটা কেন বলছি, কেন লাগবে এই রেস্ট্রিকশন বা এই প্রপার্টিটা কেন দরকার, পার্টিকুলারলি ডেটা স্ট্রাকচারের অ্যালগরিদমের জন্য বা ডেটা স্ট্রাকচারের মেমরির জন্য? এটা কেন আমরা মেনশন করছি?
যত এফিশিয়েন্ট তত কম সময় লাগবে। মানে যদি মানে যদি একটা ওয়েবসাইট ভিজিট করো নাকি আর একটা অ্যালগরিদম অনেক টাইম লাগে, তো বেশি ইউজারকে হ্যান্ডেল করতে পারবে না সেখানে।
আমি আরেকটু ভালোভাবে বলবে, মানে তোমার কথাগুলো শেষের দিকে কম, মানে ভলিউম কমে যাচ্ছে, একটু জোরে জোরে বলো।
মানে বলছিলাম, সাপোজ যদি একটা ওয়েবসাইটে গেছে, ধরো যদি আমরা একটা সর্টিং অ্যালগরিদম ইউজ করছি, তো সেখানে সর্টিং অ্যালগরিদমটা যদি অনেক বেশি টাইম নেয়, তো আর অনেক ইউজার এসে অ্যাক্সেস করতে চায়, তাহলে মেমোরি ওভারফ্লো হয়ে যেতে পারে সেক্ষেত্রে। কিন্তু যদি আমরা সেটাকে আরো এফিশিয়েন্ট করতে পারি, তাহলে খুব কম সময়ে সেই রিকোয়েস্ট গুলো সেন্ড করা যাবে।
একটু গন্ডগোল হয়ে গেল, তুমি অ্যালগরিদমের টাইম বলতে গিয়ে মেমোরি বলে দিলে। হ্যাঁ, তোমাকে পরিষ্কার মানে চিন্তাধারাটা একেবারে ক্লিন করো। হ্যাঁ, তুমি প্রশ্নটা মানে যে উত্তরটা দেওয়ার চেষ্টা করেছো সেটা খানিকটা ট্রু, কিন্তু আমি ঠিক ওই লেভেলে যেতেই চাইছি না। আমি ওয়েবসাইট লেভেলে এখন যাবো কোথায়? আমি তো সি ল্যাঙ্গুয়েজে প্রোগ্রাম করছি। হ্যাঁ, আমি নিজের বাড়িতে বসে সি ল্যাঙ্গুয়েজে প্রোগ্রাম দিচ্ছি, তাতেও এটা ইম্পর্টেন্ট। সেটা কেন?
মেমোরি পরিমাণ ফাইনাইট, বেশি মেমোরি লাগলে এখন দেখা যাচ্ছে অত মেমোরি সাপ্লাই দেওয়া যাচ্ছে না, এটা একটা কারণ।
তার জন্য পার্টিকুলারলি ডেটা স্ট্রাকচারের জন্য এই মানে ডেটা স্ট্রাকচারের ব্যাপারে এই ধরনের আমি কমেন্ট করবো। মানে
মেমোরি অ্যালোকেট করতে ডিঅ্যালোকেট করতে টাইম যাবে
না, এই কমেন্টটা হচ্ছে পার্টিকুলারলি ডেটা স্ট্রাকচারের সঙ্গে রিলেটেড যে সমস্ত অ্যালগরিদম বা মেমোরি দরকার সেইটার কথা। হ্যাঁ, সেটার কোনো ইয়ে আছে, মানে কারণ আছে বলে তোমাদের মনে হচ্ছে?
কেন ডেটা স্ট্রাকচারে ডেটা স্টোর হচ্ছে, এবার কত ডেটা আসবে সেটা তো সবসময় হাতে থাকে না। আমরা না স্মল ডেটা ইউজ করতে পারি, কিন্তু লার্জ যদি ডেটা সেট হয় তখন তো এফিশিয়েন্ট না হলে রান করবে না।
আমি একটু হেল্প করে দিচ্ছি তোমাদের। হোয়াট ইজ এ ডেটা স্ট্রাকচার সেটা আগে বলো। এতক্ষণ আমরা বললাম যেটা
data structure is something that efficiently organizes the data.
না, আমি এতক্ষণ ধরে কি বললাম? এতক্ষণ ধরে ডেটা স্ট্রাকচার ব্যাপারটা কি?
ডিজাইন এন্ড ইমপ্লিমেন্টেশন অফ অ্যান এডিটি।
ডিজাইন অফ অ্যান এডিটি, তাই তো? সেটা ডেটা স্ট্রাকচার, বা ইমপ্লিমেন্টেশন অফ অ্যান এডিটি, সেটা হচ্ছে ডেটা স্ট্রাকচার। তাহলে ডেটা স্ট্রাকচার অ্যাকচুয়ালি আমাকে দিচ্ছে কি না এডিটি। হোয়াট ইজ অ্যান এডিটি? পুরো কথাটা কি?
abstract data structure type.
Abstract data type, right? Abstract data type. তার মানে কি, it is nothing, data structure is nothing but a type. Okay, তাহলে যে কোনো একটা টাইপ, if I declare a type, I can define many variables of that type in my program, তাই না? এটা যেহেতু একটা টাইপ, নাথিং বাট এ টাইপ, তাহলে কি হবে? যে কোনো টাইপে আমি ভেরিয়েবল ডিক্লেয়ার করতে পারি। এবার সেই কতগুলো ভেরিয়েবল ডিক্লেয়ার করবো সেটা ডিপেন্ডিং অন মাই রিকোয়ারমেন্ট। প্রচুর ভেরিয়েবল ডিক্লেয়ার করতে পারি। তাহলে প্রচুর ভেরিয়েবল যদি ডিক্লেয়ার করি তাহলে প্রচুর মেমোরি লেগে যাবে যদি মেমোরি ইউসেজটা ঠিকঠাক করে না দেখি। নাম্বার ওয়ান। নাম্বার টু, আমি একটা পার্টিকুলার টাইপে ধরো 10খানা ভেরিয়েবল আমি ডিফাইন করে রেখেছি। এবার সেগুলোকে আমার ম্যানিপুলেট করতে হচ্ছে ইউজিং দ্য data structure operations of the data structure, and the operations are written using the algorithms. So ওই যে আমরা ইউজ করব ইয়েগুলোকে, ওই যে আমরা অপারেশনগুলোকে ইউজ করবো, সে অনেকবার ইউজ হতে পারে, মিলিয়ন টাইমস ইউজ হতে পারে। তাহলে মিলিয়ন টাইমস ইউজ হতে গেলে আমার যদি অ্যালগরিদমগুলো টাইম এফিশিয়েন্ট না হয় তাহলে প্রচুর সময় লেগে যাবে। সো ফরগেট অ্যাবাউট ওয়েব, ফরগেট অ্যাবাউট সর্টিং। সর্টিং ইজ ভেরি ইম্পর্টেন্ট, আমরা পরে দেখবো সার্চিং অ্যান্ড সর্টিং। কিন্তু এনি কাইন্ড অফ ডেটা operations, I mean data structure operations, and any kind of data organization must be very efficient for memory and algorithms, memory and time. Okay, বোঝা গেছে? তাহলে আমি যখন ডেটা স্ট্রাকচার, আমি এডিটি থেকে যখন ডেটা স্ট্রাকচারকে বলবো, ডিজাইনটা যখন বলবো, তখনই আমাকে ডিজাইন লেভেলেই যথেষ্ট সাবধান হতে হবে যাতে মেমোরি অ্যান্ড টাইম বেশি না লাগে। And naturally that will percolate down to the implementation level. ইমপ্লিমেন্টেশন লেভেলে গিয়েও আমাদের একই রকম সাবধান থাকতে হবে যে মেমোরি যেন বেড়ে না যায় আর টাইম যেন বেড়ে না যায়। ওকে, সো দিস ইজ হোয়াট ইজ ইন শর্ট ADT and data structure is. So in the next few classes, what we do, I mean, let me go through the summary. Data type and structured data types are discussed. Algorithm structures are discussed. Abstract data type, data structure, and implementation, they are defined and exemplified, and static and dynamic data structures are discussed. So that is what has been done in this particular class. Okay. So now we'll stop here, and I'll send you this particular thing today, and of course we cover show particular যেটাতে ছবিগুলো আঁকা আছে এগুলো পাঠিয়ে দেবো। সো নেক্সট ক্লাস কবে করবে সেটা একটু আমাকে জানিয়ে দিও। আমাদের বোধহয় একটা ল্যাবের কথা আছে, আমরা নেক্সট উইকে ল্যাবটা আরম্ভ করবো।
নেক্সট উইকে স্যার আপনি ল্যাব শুরু করবেন?
নেক্সট উইকে করব।
A1 এরই আছে মানডে আই গেস। হ্যাঁ,
মানডে A1 আছে, সেকেন্ড হাফ না?
হ্যাঁ, সেকেন্ড হাফটা পুরোটা।
সেকেন্ড হাফটা আছে, ঠিক আছে। তাহলে সেকেন্ড হাফে আমরা A1 এর ইয়েতে
আমি স্যার ঋষভ
তুমি কে সেটা জানতে?
ঋষভ
হ্যাঁ, ঋষভ হচ্ছে। ঋষভ, তুমি আমার একটা মেল পাঠিয়ে দেবে।
আচ্ছা, ঠিক আছে। ল্যাবের রিগার্ডিং
তুমি আমাকে একটা মেল এমনি পাঠিয়ে রেখো, আর ল্যাবের ওই তোমাদের A1 এর যে লিস্টটা আছে সেটাও পাঠিয়ে দেবো।
আচ্ছা, ঠিক আছে, পাঠিয়ে দেবো।
ঠিক আছে,
হ্যাঁ স্যার। আচ্ছা, আপনার 8টা থেকে 5:30।
করার থেকে কটা আছে?
2:30 থেকে 5:30।
হ্যাঁ, আমি হয়তো অত তাড়াতাড়ি শুরু করবো না, নাও করতে হয়, কারণ 8 সেকেন্ড আছে। হ্যালো,
হ্যাঁ স্যার। হ্যাঁ স্যার, বলুন।
ঠিক আছে, দেখা যাবে, ওটা আমার পাঠিয়ে রাখুন।
ওকে,
দেখে নেবো।
আচ্ছা, ঠিক আছে।
ঠিক আছে, দেখে নেবো। ওকে, তাহলে দেবাশিসের কথাটা জিজ্ঞেস করবে ইমপ্লিমেন্টেশনের ব্যাপারে। ওই যে তোমাদের ক্যাবিনেট ইমপ্লিমেন্টেশন, ঠিক আছে, পরে আমি ক্লাসটা শেষ করি। ওকে, হ্যাঁ, তাহলে ঋষভ, তুমি আমাকে তোমার ফোন নাম্বারটাও একটু পাঠিয়ে রেখো, হবে না? কোথায় রেখেছি একটু মনে নেই।
আচ্ছা ঠিক আছে স্যার,
ফোন নাম্বার আর একটা মেল পাঠাও, আর ওই লিস্টটা পাঠিয়ে।
ঠিক আছে স্যার, ঠিক আছে।
আমরা শুরু তো করি, তারপরে
ঠিক আছে।
ঠিক আছে
স্যার ইয়ে সেদিন যদি মানে কেউ চায় অফলাইনে গিয়ে কি কেউ ল্যাব করতে পারে, মানে এরকম কিছু আছে কোনো প্রভিশন?
পরে কথা বলে নেবো, তোমার ফোন নাম্বার আর ইয়েটা পাঠিয়ে।
আচ্ছা আচ্ছা আচ্ছা,
পরে কথা বলবো, কারণ আমার আসলে ওই দিন সোমবার দিন কয়েকটা মাস্টার্সের ভাইভা আছে।
আচ্ছা আচ্ছা ঠিক আছে,
টাইমিংগুলো আমি একটু দেখে নিই।
ঠিক আছে ঠিক আছে।
কিন্তু আসতেই পারো, না আসলে কোনো ক্ষতি নেই। ঠিক আছে, ঠিক আছে, তাহলে আজকে আমরা শেষ করছি এখানে। ওকে, থ্যাংক ইউ, আমি লগ আউট করছি।